Welcome to the ultimate mega factory. Here, advanced robotics meet It is a symphony of engineering. Precision is everything. A single degree of temperature change can ruin an entire batch. Operating with 90% automation, robots and conveyors move in perfect sync, maintaining hospital-grade hygiene standards. We've evolved from the gritty drinks of the Aztecs to a velvet texture that was chemically impossible just a century ago.
But the magic doesn't start here. It begins thousands of miles away near the equator. Let's track the raw ingredients.
It starts with the cocoa bean. Massive trucks deliver tons of fermented beans, sourced primarily from Ghana and the Ivory Coast.
Every sack is inspected. We check moisture levels immediately. If they are too wet, mold could destroy the whole silo.
We perform the cut test. We need a rich brown color inside. Purple means it was under-fermented and bitter.
Once cleared, beans are vacuum-sucked into massive silos, holding 100 tons each, keeping them cool and dry.
It's not just cocoa. We consume 50 tons of sugar and 30 tons of milk powder every day for our recipe. To make chocolate, we need the nib hidden inside the bean. But first, we must clean the batch of debris.
Vibrating sieves and powerful magnets remove twigs, stones, and anything else that might damage the grinders.
Optical sorters scan every single bean. High-speed air jets blast away any defectives. Only premium beans survive.
This is micronizing. Infrared heat swells the beans, cracking the hard outer shell so it peels off easily later. The raw materials are prepped. Now we apply high heat to unlock the chemistry of chocolate. It's time to roast.
The beans enter the drum roaster. This is where flavor is born through the Maillard reaction, browning the proteins.
We roast at 130 degrees Celsius. Dark chocolate gets high heat, milk chocolate gets a gentle roast.
They must be cooled immediately. If they'll stay hot, they will burn from the inside out, ruining the flavor.
The winnower crushes the beans. We want the meat, the nibs, but we have to separate them from the papery shells.
Using airflow, the light shells are blown away into a waste chute. These are often recycled as fuel or mulch.
We are left with pure cocoa nibs. These are 50% cocoa solids and 50% fat, the precious cocoa butter.
The nibs enter the mill. The intense friction generates heat, melting the natural fat trapped inside the solid cells.
The result is chocolate liquor. It's not alcohol, it's pure, liquid, unsweetened chocolate flowing like thick syrup.
Here the path splits. Some liquor goes to mixing, but we need extra butter, so the rest goes to the hydraulic press. Under 12,000 pounds of pressure, we squeeze the liquor. Golden cocoa butter drips out, leaving a hard cake behind. That hard puck is pulverized to make cocoa powder. But the gold liquid, the butter, is what makes chocolate melt.
We now have our components isolated. This allows the master chocolatier to control the exact fat-to-solid ratio.
For our milk chocolate bar, we will combine the liquor, the extra butter, sugar, and milk powder. Processing is done. We move to the mixing deck, where industrial chemistry meets culinary art. The ingredients are staged. It is time to combine them into a paste that will eventually become a bar.
Into the mixer goes liquor, butter, sugar, and milk. At this stage, it feels like wet, gritty sand.
It's gritty because sugar crystals are 100 microns wide, too big for the tongue, which detects anything over 30. To fix this, the paste travels up the 5-roll refiner. Steel drums shear the particles down to microscopic sizes. As it ascends, the paste transforms into a dry flake. The particle size drops from 100 microns to just 18. It is smooth now, but the flavor is acidic. It needs to be conched, the most critical step in chocolate making. Invented by Rodolphe Lindt, the conch shears, heats, and aerates the chocolate for hours, sometimes days. Friction heat coats every sugar particle in cocoa butter. The dry flakes magically transform into a flowing liquid. Heat drives off volatile acids, removing the sour vinegar notes, and leaving a mellow, rounded flavor.
We add a dash of soy lecithin. This emulsifier reduces viscosity, making the chocolate flow like silk.
High-quality chocolate conches for up to 72 hours. The longer the conch, the smoother the flavor.
Robots sample the batch to test viscosity. If it's too thick, it won't mold correctly. It must be perfect.
The conching is done. The chocolate is delicious, but we can't mold it yet. It needs to be tempered.
We must align the crystals. Untempered chocolate crumbles. Tempered chocolate snaps and shines.
It sits in heated tanks at 45 degrees Celsius, keeping all fat crystals melted, waiting for the tempering machine.
It travels through jacketed pipes, pipes within pipes filled with warm water to ensure it doesn't freeze en route.
This is the tempering column, a heat exchanger that takes the chocolate on a specific temperature roller coaster.
Cocoa butter has 6 crystal forms. Only one, form 5, gives us that perfect finish. We must force it to form. We cool it to 27 degrees to form crystals, then gently reheat to 31 degrees to melt the unstable ones.
Reheating melts the bad crystals, but leaves the stable beta crystals to act as seeds for the rest of the batch.
Operators check the temper index constantly. The machine automatically adjusts temps by fractions of a degree.
The chocolate is now stable. It has a glossy sheen and will shrink slightly when cooled, allowing it to pop out of molds.
If this were a nut bar, we'd mix in roasted hazelnuts here. But for pure milk chocolate, we head straight to molding.
The molding line moves at a staggering pace. Empty molds are preheated so they don't shock the warm chocolate.
Hygiene is key. Molds are inverted and air blasted to ensure no dust or old crumbs remain. We are ready to pour. The depositor is the heart of the shaping process.
Piston-driven depositors inject the exact weight into the molds, filling up to 10 bars per second.
Immediately after pouring, the chocolate is uneven and full of trapped air bubbles. It needs to settle.
The molds hit a vibrating table. The shaking forces bubbles out and spreads chocolate into every corner of the logo.
Now, into the cooling tunnel. A multi-zone climate tunnel that mimics a brisk autumn day.
We cool gently, 20 minutes traveling through zones ranging from 10 to 18 degrees. Too fast, and it turns gray.
As the crystals solidify, the chocolate contracts. It literally shrinks away from the mold walls.
At the end of the line, the molds are inverted. Plastic hammers give them a gentle tap to release the bars.
Thousands of bars rain down. The empty molds loop back to the start to be cleaned and refilled.
Notice the shine. That glossy finish is the proof that our tempering process was successful.
Adjacent lines might be using spin molding for hollow figures or cold stamping for filled truffles.
The bars are solid and ready. But are they safe? We have to check before we wrap.
If the wrapper jams, bars divert into a spiral buffer tower, buying operators time to fix the issue.
Before a single wrapper is applied, the bars must run the gauntlet of quality control.
Every bar passes through a metal detector. Even a shaving of steel will trigger the alarm.
If a defect is found, a pneumatic arm instantly kicks the bar into the reject bin. No mercy.
Dynamic check weighers ensure accuracy. If the label says 100 grams, it mold be 100 grams, never less.
Vision systems verify the look. If a bar is chipped or the logo is scratched, the AI camera rejects it.
Robots measure weight, but only humans judge taste. Sensory panelists test samples every shift.
Technicians also use lasers to confirm particle size. If it's too coarse, the grinders are adjusted.
These bars have passed every test. They are safe and consistent. Now, we dress them up. The flow wrap machines handle 600 bars per minute. That's 10 bars every second. The foil wrapper seals the chocolate hermetically, protecting it from light, moisture, and odors.
A laser etches the batch code. We can track a specific bar back to the specific bean sack it came from.
Delta robots use suction cups to grab wrapped bars and arrange them perfectly into display boxes.
Automation handles the cardboard too. Robots fill the boxes, and tapers seal them shut. A heavy-duty palletizing robot stacks the boxes in a specific pattern for stability during transport. The final step is stretch wrapping. This secures the load for its journey to the distribution center. No drivers here. Automated guided vehicles scan the room with lasers to navigate the pallet to storage.
The warehouse is temperature controlled. We can store up to 10 million bars here before shipping.
Logistics networks take over, distributing these treats to supermarkets and vending machines worldwide. From a bitter bean drying in the sun to a precision-engineered delight, the journey is immense. In the 12 minutes you watched this video, this single factory produced nearly 5,000 bars.
It is a process defined by heavy machinery, yet the result is personal, simple, and universally loved.
Next time you hear that snap, remember the engineering and chemistry that made it possible.
If you enjoyed this tour, hit like and subscribe for more deep dives into how the world works. See you next time.